Hello, I'm Alfred Vinoth,
Hello, I'm Alric Vinoth.
and our project is Future Evolution of Homo Sapiens. What is the purpose of our project?
Well, the purpose of our project is to anticipate how humans will evolve in the future after a global submergence, and how advances in technology will lead to a precipitous human evolution due to artificial selection. But what is evolution?
Over generations, every biological species may undergo changes, both psychologically and anatomically. This process of change and development is known as evolution. But how did humans evolve in the past? Well, similar to most species, humans evolved through a process known as natural selection.
Natural selection occurs when a generation passes down the best suited genes to the generations after them, so that these newer generations can thrive in their environment. But what is our question?
Well, our question is, will the advancement of technology be the determinant of accelerated human evolution?
In our theory, we answered this question starting with the melting of Antarctica.
Way down south, in West Antarctica, lays the Thwaites Glacier. Scientists are very worried about this glacier because it's rapidly melting. If it melts, it can collapse all of West Antarctica with it due to its position in West Antarctica. This will raise ocean levels by 3 meters, but although that might not seem like much, it can submerge many cities and rapidly start chipping away at East Antarctica. And that is the start of a global submergence.
This is where our theory splits off into 3 different branches. These branches include living underwater, living on mountains, or living on planet Mars. In branch 1, scientists will have made underwater pods that can support humans in their dire times. The way they would breathe in these pods is by having specialized ventilator systems that can extract the oxygen from their H2O environment. The remaining hydrogen would then be used for other purposes such as fuel. Some anatomical changes these sea humans might experience would be larger eyes to see better in their dark oceans, or fatter bodies to sustain heat in their cold environments.
In branch 2, humans will move to the high mountains to escape from the water. They will build civilizations as they once did before, but they will need a constant oxygen supply due to the lower oxygen levels at the high altitudes. Some anatomical changes these humans might experience through natural selection would be larger lungs to store more oxygen in their bodies, and bigger bodies to store heat better in this frigid environment.
Branch 3 is the most ambitious, dangerous, and exciting one out of these 3 branches. This is because humans would become a multi-celestial species if we do travel to Mars. According to NASA, a trip to Mars would take about 9 months. If you wanted to make a round trip, it would take about 21 months. It would become 21 months because you would have to stay 3 months on Mars to make sure Earth and Mars are both in a suitable location to make the trip back home. Space travelers will experience these changes.
1. Blood circulation won't operate accurately because there isn't any gravity. 2. Bone density can decrease because the production of osteoblasts lessens, and bones aren't being used to hold the usual body weight they do on Earth.
Also, one's muscle mass can reduce as there's barely any weight in the environment to work out these muscles. These problems can make humans look very out of the ordinary.
When humans do finally reach Mars, life won't become any easier as they will need to wear radiation suits and pressure suits every time they step outside. These pressure suits can prevent vacuum bruising, which is caused by small exposures to the vacuum of space, and that can lead to the embolism of the blood, making tissue start to bruise and swell. But how will they make Mars habitable?
First, humans will find shelter in their 3D printed homes that were constructed by the drones or robots sent before them. These 3D printed homes will have water recycling and filtering systems, and a device that can extract oxygen from the carbon dioxide in the atmosphere. Mars is very frigid. Its average temperature is negative 81 degrees Celsius, which is immensely cold. To solve this problem, humans will have to pollute the air and do global warming, like how we do here on Earth. This process of transforming a planet is known as terraforming. As technology flourishes in this futuristic world, scientists will have mastered their molecular editing devices and external prosthetics, the most important one being gene editing. The short answer to our question is artificial selection. But what is artificial selection? The act of using technology to edit one's own traits is known as artificial selection.
Artificial selection will be the reason humans have an enhanced evolution, as it can alter DNA instantly rather than over generations as natural selection does. Most importantly, artificial selection can be used to remove any unwanted traits that may harm a human and reverse aging.
How will artificial selection be useful for everybody? In Branch 1, humans living underwater might find it useful that they can breathe underwater. Humans will greatly benefit from this as they are surrounded by mostly water. They won't need to use submarines for short commutes, but instead they can simply swim to their destination. Branch 2, humans living on mountains shall have enhanced eyesight through the use of gene editors. Their eyes will be able to see heat signatures, which can greatly help them on their foggy days, which occur a lot.
Humans residing on Mars can use gene editing to solve multiple issues they have there. They can use it to resist the toxins throughout Mars's atmosphere, the colder temperatures, and the harsh UV rays that leak through Mars's thin atmosphere.
What are our conclusions?
Well, if humans prevent the melting of Antarctica, it would be rare that they experience any anatomical changes due to the safe and comfortable environment.
Although these theories sound far-fetched, the future is approaching quickly. There's no need to think small about the future, because what humans used to think was science fiction 100 years ago is now our reality. The future is filled with opportunities and challenges that might make humans very different than how we have predicted, but none can know for sure as the future is unpredictable.
Thank you, judges, for your time and dedication toward the advancement of science.
Thank you, and bye.